Hey, this is Mr. Mitchell with another video. Go ahead and write down the questions. Today we're going to talk about simple machines. Simple machines, well, you may be surprised how other machines can kind of trace their origin back to these 6 simple machines. All other machines are either modifications of simple machines or they're combinations of simple machines. These simple machines can be broken down into two families. One family is the lever family. Let me get something I can underline with. Oh, let's go with green. The lever family and the inclined plane family. Now what we're going to do is we're going to go over each one of these 6 kind of simple machines and give you examples. First example, of course, is going to be the lever. Now a lever here is going to be some kind of flat um, object like a stick or something that you can set on a fulcrum, which of course can be a rock or many things you could set up under the stick to use to help. Here this guy has no hope of moving this rock on his own, but with the help of a lever that he can place this way, he can push his force down and then that pushes up the rock. So it's a simple machine, probably even cavemen probably would figured this part out about levers, and here we are today. I mean, it's one of the ways you can move things. Let's go to another slide, and we'll continue to talk about levers. So we've got 1, 2, 3 different kinds of levers here. There are 3 classes of levers, and first class is this kind, and this is the most commonly used lever kind, and this is just like we had before. You have the force going down on one end, you have a fulcrum that's somewhere in the middle, and you have whatever you're lifting on the other end. So you go down on one side and the load is lifted up on the other side. Now there happens to be a couple of modern day adaptations to this. Here we have a crowbar. We'll go down to this one right here because it's kind of the simplest one. Here we have a crowbar. The crowbar has a little hook right there, and you go down on this side, and on this side it will go up. Now one that you might not expect here is this guy with an oar. This oar here is going to be the same type thing, except it's not as heavy an object here. Here you have the water. This guy without this lever here could put his hands down and paddle, but he's not going to have near as much paddling effectiveness unless he has some kind of simple machine like this. Fulcrum, of course, is going to be right here in the middle. He's having effort going back toward him here, which means you're going to have the effort going forward here, and it will move the boat. So it's kind of like lifting the water or pushing the water wherever you want it to go, just like you'd push the rock wherever you want it to go here. A second class lever looks like this. Notice that the second and what will be the third class lever off to the right here, my right anyway as I'm looking through it, I guess it's your right too, have the fulcrum at the end. Now these are not as common here, but you're using your force. Both cases you're using your force to lift up the stick-like lever. And in lifting up the stick-like lever, you're able to lift things a little easier. Here you have a wheelbarrow. You have the fulcrum, which is at the end. That's kind of what stays still. In this case, it's where the wheel happens to be. And you're lifting up this heavy load. You probably could not lift up this heavy load if you were to just use your hands, but you use the wheelbarrow lever in which to lift it up. The load is in the middle, and the force is going to be on the outside. And it's not going to have the mechanical advantage that this one is going to have, but it is something that's a practical use of a long level thing, which is what a lever actually is. Now look at this modern contraption. I guess it's not so modern, but you have this cracker here, which basically is 2 levers. It's 2 levers, and officially it's going to be a second class lever because you have the fulcrum that's right at the very end. You have the load that is in the middle, and you're pushing down on each side. And what's going to happen is it's going to push in and serve to crack this open just like you would expect it to. So that's actually 2 levers put together, even though you probably wouldn't expect that to be like a simple machine. Here we have a third class lever. Third class lever is one where you have the load at the end and you have the fulcrum still at the middle or at the other end, and the force is going this way. Now this is often used in our body. The fulcrum is often our joints, and if you look at this, here's an example. Don't know why I picked one where it's just a skeleton doing it, but we'll go with it. Here we have the fulcrum that is right here, and they need to lift up the load, which is at the very end. So it's just a matter of going up, using the muscles going up like that. Here's probably a better example. Here we have, and I don't know if you can see from my face down here, here we have the arrow with the baseball player. He's got the fulcrum, which is at the very end. That's what he's controlling, where his hands are. The load is going to hit around the end here, and he is just pushing the force through. It's kind of like using that lever, that long stick thing, to push something. And that's kind of what a third load would be, third class lever would be. And here we have the tennis racket, which is kind of a similar thing to the baseball bat. Now let's go to a different simple machine. A second simple machine is called a pulley. So we have a lever, we have a pulley. Here you have a weight. Let's go to this one because it has a bigger weight here. We have a 100-pound weight, which is probably going to be pretty hard for somebody just up and lift up on their own. So by having this pulley here, where you can put some kind of rope over the top of it, and this spins around up top here, then you can pull it down this way. You're putting your force down this way, and it lifts this thing up right here. Now the mechanical advantage is about a 1 for something like this, which is pretty good. I mean, if you have a mechanical advantage of 1, it is helpful to you. Here, you actually have a mechanical advantage of 2 if you were doing something like this. Now, just by looking at this lever, having the rope going down and then coming up, you might not know where the weight would be. The weight would be attached to the lever itself. So what you're doing, you're standing up here. How's that for a stick figure? You're standing up here and pulling on the rope, and you're actually doing the lifting up. And it actually has a pretty good mechanical advantage. It's easier than just taking the thing and lifting it itself, and you actually have a little bit better, more advantage than you do here in this one. And if you use 2 levers, you have 2 pulleys, you have a mechanical advantage of 3. And you can see the deal here. You're not only lifting up on it, you're lifting it through a lever, through a pulley here, that is actually doing the lifting for you. Now in this case, he's pulling, that will pull, and the arrow says it's going down here, but this would actually go up right here is what it would end up doing, because it's lifting this whole thing up. And that's one way you could lift it up, and it's going to be easier. The higher the mechanical advantage, the easier it is on the human. Let's go to another simple machine, is wheel and axle. Now this is the last one that's in the lever family. A wheel and axle is kind of like this. You have a wheel that is attached to something that's in the middle. So when you turn the wheel, it's going to turn this axle here, which kind of looks like a lever, but you're using it to, in most cases, coil things up. It would be harder to take this pail of water and go down and lift it by hand, but if you have some kind of wheel and axle, then the energy you're expounding is just in the turning of that, and it wheels up the axle right here. A car is a good example of one, the car steering wheel. You have the wheel, which is the steering wheel, and it is attached to this long thing here, the axle, which is attached to the actual wheels. So you can just make a simple turn one direction, and it makes the car turn in that direction. A very good example of a wheel and axle. You might not have realized that a doorknob is a little bit like that. You have this, which is the wheel knob itself. It is attached to a long thing here like an axle, and it moves that lever just like you want it to. And even a pencil sharpener has that wheel action. It is attached to an axle there, which does all the work for you. Pretty clever, these simple machines. Oh, let's see where I am. Let's go down to an inclined plane. Now there are 3 in the inclined plane family, and you can kind of see how this is different from a lever. Sure, the inclined plane kind of looks like a lever, but you're using the position of it, I guess you might say, instead of pushing some kind of force. Here, it is easier to move this dresser up a ramp than it is to just lift it up. What it does, it redirects the force. It redirects the force, and the longer the ramp, the better the mechanical advantage. But naturally, it's impractical to have a 100-foot ramp here to carry a 100-foot ramp around. So if you have a short little ramp, it helps on the mechanical advantage as opposed to just lifting it up. And you may not have thought about this, but steps are an inclined plane. Sure, it would be very hard for you to go from one level to the next stepping straight up. In fact, you'd have to do some kind of climbing, or you could jump like you're in the NBA. But here, this takes your body one level at a time and is a fairly easy type thing in which to maneuver. Also in the inclined plane family is the wedge. The wedge here is basically 2 inclined planes. 2 inclined planes, and you're using those 2 inclined planes, of course, to cut wood or to go in things. A wedge, you also have nails, which are wedges. If you drive this in, you're using that kind of like a wedge and going into things. We have a screw, which is, a screw looks a little bit like a nail because of its length and because of its shape. But the inclined plane in a screw is not just at the very end. The inclined plane at the screw goes all the way around it. All these little grooves is like an inclined plane that is going all the way up. So what you're doing whenever you're putting it in some kind of wood or something and it starts to turn, the inclined plane that is touching it is going to get inside the wood. So it's just going to use that inclined plane the entire way through, and you actually have an inclined plane touching it all the way through, touching the wood all the way through to the very end there. So that's why you can categorize that with the inclined plane portion of simple machines. Now, a compound machine is using one or more simple machine. Scissors are a good example. Here you have levers. The fulcrum is right here, and you also have a wedge. Right here where you're cutting, you have a wedge. You have an inclined plane going on one side, inclined plane. It comes to a sharp point. So you have a wedge here, and you have the levers right here with the fulcrum right there. So that's an example here. You have a wheelbarrow. We've already mentioned that a wheelbarrow can be like a lever, but it also has this wheel and axle right here. The wheel, the axle that goes through it right there. So that's an example of 2 of them. Here you have a wedge on the end of this front end loader. I think that's what you would call it. And you have a lever that is right here. And you could probably trace quite a few simple machines to becoming compound machines. Hey, I hope you've learned a little bit in us touching about these simple machines. And hey, don't forget to read about this in your science book.